Hello, hi everyone, and welcome to another episode of The Secure Developer. If it's your first time with us, we are an inclusive community that aims to educate and enable developers in application security. I'm joined today by Jimmy Mesta, and he's going to be talking about the state of Kubernetes security. But before we get started, quickly want to introduce myself. I'm Sam Hepburn, and I'm the community manager that's working behind the scenes to make this all happen. So any questions, feedback, session ideas, topics, please let me know, tweet, jump onto the Slack, ping us on the website, which is thesecuredeveloper.com. The Slack is actually the best way to engage with Jimmy today. So if you're not part of the Slack group, if you jump onto thesecuredeveloper.com and go to join Slack, you'll be able to chat with him on live sessions channel and get your questions across to him. One other bit of housekeeping is in the bottom right-hand corner, you'll see a little cog. If you could up your resolution, that's the best way of watching the live stream today. And a huge thank you to the team at Sneak for powering this community. So we're able to have a vendor-neutral community with their backing. So huge thanks to them. But other than that, that's enough from me. I'm actually going to hand over to Jimmy. So Jimmy, welcome to the Secure Developer.
Awesome. Thank you, Sam. Hello, everyone. I'm in the Slack. I'm here. We're ready to roll. Again, my name's Jimmy. I'll get to that in a second, and we are going to talk about the state of Kubernetes security. Here is a lovely picture of our State of the Union address here in the United States, not a current one. I have some new stuff to go over today. If anybody's ever attended a webinar of mine or a training or anything like that, this will be a little bit of a new format just for the secure developer. So I'm really excited to be here. I've been ready for this for like 2 months. So let's do this. So again, I'm Jimmy. Hi, I'm in the chat. We're live. Let's do this. I work at a few companies. I'm an independent consultant, mainly working on some Kubernetes security products as well as training. So if here's my one marketing thing, if you want me to come on site and teach at your organization for 1, 2, 3 days, specifically on Kubernetes security, I do that, and I do a lot of other Kubernetes stuff. I'm not sure how I totally fell into this Kubernetes space, but I've been doing security for about 11 years and Kubernetes security specifically for like 3, which is basically like dog years. It's just 21 years of Kubernetes security. No, I'm just kidding. So today we are going to spend the next hour talking about all sorts of things, right? Pertaining to Kubernetes. Number one, we're going to start with what are containers, right? How do they fit into this ecosystem? It's often overlooked that container security needs to be kind of at ground zero of what's going on in inside your Kubernetes cluster, because as we all know, or maybe we all don't know, we'll find out that Kubernetes relies on containers to operate and to provision workloads. So we're going to spend some time on containers and what that means and how they fit into Kubernetes as a greater orchestrator. Then we're going to talk about Kubernetes itself, right? This is the hottest buzzword of 2018 and 2019, and probably even more so next year, right? So Kubernetes is on top of mind everywhere. So what is it? Why do I care as a security professional? This is the Secure Developer podcast and screen share. So as a developer, like, what does Kubernetes mean to you, right? We're not going to spend too much time on a deep dive. We don't have all the time in the world, but we're at least going to scratch the surface of why we use this thing and what it was built for. And then how do we start considering security around it, right? Because as we'll discover, Kubernetes is not actually secure by default, contrary to popular belief. Unfortunately, that is not the case. And then a little brief Kubernetes self-assessment, I'm calling it. This is kind of a new hodgepodge of things that if you take this slide that's probably has way too many words and lines on it, and you sit for a day or over lunch or something and kind of assess your own Kubernetes environment and make sure you know how to answer the questions that are being presented as part of this little mini self-assessment. And then we're going to discuss the future of Kubernetes security somewhat briefly, just kind of my thoughts on where things are going as we roll out into a mature, stable, open source project. what's happening, right? Who's working on what, and what are we actually doing to make systems more resilient. And I do have my Kubernetes shirt on today, because this is basically represents a Kubernetes cluster, a magical unicorn, and lots of rainbows and a castle. So that's what we're going to talk about for the remainder of the day, right? So let's start with containers. As I mentioned, this is the fundamental building block of Kubernetes, right? We don't really run Kubernetes or deploy workloads or applications or microservices inside of Kubernetes without using containers. This isn't Docker specific by any means, but if I do use Docker in my demo or say the word Docker, that's interchangeable with other container build systems and container runtimes. It's just the most popular. So at its core, there's another castle, right? Containers are an application layer construct. And this application layer construct relies on a shared kernel. This is a really important notion before we dive into the nitty-gritty security defense mechanisms and kind of the attack scenarios inside of Kubernetes. We have to understand that we're operating in a shared environment, right? Those of us who are familiar with virtual machines, this isn't really a virtual machine, right? We're not talking about a lightweight virtual machine. Again, this is kind of a hot take compared to what some folks will call containers, but I don't like that terminology because it doesn't really get to the core of what we're trying to secure, right? If we're familiar with a virtual machine, on the left here, we see a host operating system running on bare metal infrastructure with its own hypervisor layer, right? And that hypervisor layer it's software, but it provides a very strong isolation and lets you isolate and separate different guest operating systems on that same piece of infrastructure. So this model here gives you 3 separate kernels, right? 3 full-blown guest operating systems. And that's vastly different than our container infrastructure, right? Here, instead of having 3 separate kernels, for example, on this one piece of infrastructure, call it a server or a laptop, we're going to share that host operating system. And we're going to apply this layer called a container runtime, right? That is what we know of as Docker. That is what we know of as Cryo or Podman or anything that's going to act as our container runtime. And that container runtime is responsible for communicating to the host operating system's kernel, kind of the brains and meat of the operation as far as any sort of system level calls go. So instead of packaging up our application in a guest operating system with its own kernel, which could be a very large sort of endeavor and slow and it doesn't spin up very quickly. This is our EC2 model. We just have our application binaries and libraries and all the things that our application needs to run, right? So if you've ever used Docker, some of the commands Docker run, Docker pull, Docker PS, you're communicating not with your own operating system, which is why I don't like the term lightweight virtual machine. They may look and feel like a virtual machine when you exec into a running container, but it is not a virtual machine, right? There's a lot of things going on under the hood, including namespaces and cgroups. And this is kernel level isolation for a given process. So we're really trying to prevent process A from talking to or seeing that process B even exists, right? But we have the same host operating system, the same kernel. So containers really rely on a number of different technologies, even beyond namespaces and cgroups. But we're looking at a complex web of isolation that gives us this kind of environment that we call home, right? This is where our application runs. This is where our Go binary or our Ruby on Rails application is deployed to. And it's the unit of operation in Kubernetes, right? It's how we deploy applications into what's called a pod, which I'll talk about here soon. So I've heard the analogy kind of containers are akin to a apartment complex, right? And virtual machines are similar to having your own standalone house, right? If you have your own house, you can build a fence, you can change your locks, you can put gates over your windows, you can get a Doberman and have it guarding your house. And you're in control of the security to some degree of that physical structure. But an apartment complex is a little different, right? And this is kind of what a Kubernetes cluster looks like. And it has a doorman, it has an HVAC system that's shared, it has fire escapes, it has all sorts of things that are pretty much out of your control that are security boundaries. And you can live in an apartment complex that has very hardened security, or you can live in one that has none. And hopefully after today, we're going to look at our Kubernetes clusters as being an apartment complex that we'd like to live in, right? A secure apartment complex. So one of the hot topics today is container breakout, right? This is a very kind of fancy term, but and we hear about it here and there on HackerOne reports and on Twitter and things like that. But it's the problem that's plaguing container management systems and container orchestration systems such as Kubernetes, right? Container breakout is when we have defeated some of those isolation mechanisms. It's when the configurations or misconfigurations of that running container allow for an attacker via a web application vulnerability or some sort of other misconfiguration in the Kubernetes control plane. It gives that particular attacker additional privileges, right? And you've bypassed what is built in to the running container, and now you can do some stuff on the host, right? That's the big concern, is when we take a running container, which we have this perceived boundary, right? It has the word contain in it, so we want to believe and think and hope that it's actually secure, but it might not be, right? There are ways to set up Kubernetes and other container orchestration systems that could lead to container breakout, like ending up on the host as root. That's a big deal. That's exactly what we want to avoid. And that's what we're going to cover for the most part today, right? How to not set up your Kubernetes cluster to allow those sorts of things. And containers by default don't always contain, right? We have a lot of flexibility in how we deploy these things and run our applications inside of Kubernetes, but just containers specifically. So, and these all translate one-to-one for the most part to Kubernetes configurations, right? So without diving into Kubernetes first and without understanding these container kind of misconfigurations and different ways to get containers up and running, we're not going to understand what's going on in Kubernetes. So we can do things like mounting volumes and directories, right? This is really common. Oftentimes your service needs some data, or it shares data with a volume that other microservices can actually read and write to that data as well. And oftentimes containers can mount directories from the host operating system itself. Those can be read or they can be read-write, and it depends. And those have vastly different security ramifications. We can disable security features, right? So this is often referred to as the privileged mode. So when we talk about privileged containers, we're talking about containers that are not containers at all, right? They basically just tore down the boundaries through a single flag that all containers, including Docker, the container runtimes, offered to us, and we have bypassed those things. And we really want to avoid that, and we're going to see how that manifests in Kubernetes as well. Containers can run as root, or they can run as other users. And typically root is bad, right? We don't always need to run our applications as root, and we didn't do that in the past, but we're doing it because that's the easy way out. And that's kind of the default for a lot of publicly available container images. And we can share the host namespace, right? So if we're root on the host, we're not really a container. So that's kind of a really bad thing, right? You're not using containers in the right way if you're using the host namespace. So we have exploits, right? Exploits, 0 days, attacks against the kernel itself to actually go look for a vulnerability and escalate privileges from a running container that may run as root or may have privilege mode, et cetera, and break out of that container. So if you've been following the news at all in container security, run C, right? Run C, as you can see here, it powers lots of things. The underlying container runtime at a very low level, almost talking directly to the kernel of Docker, Cryo, Containerd, Kubernetes, et cetera, et cetera. So if you were running containers as your container as root, and you had this vulnerable version of run C, container breakout to the host operating system was not that difficult. So this was kind of a hurry up and patch. Oh my God, this is scary moment in the world of, public cloud providers and managed Kubernetes services, right? Because this is setting you up for disaster. Dangerous mount points. Let's see if we have any questions. Not yet. Dangerous mount points. So we have the ability to mount in directories and from the host and shared volumes and EBS volumes and all sorts of things inside of this running container, also as that translates to Kubernetes. But a common thing for some reason is to mount the Docker socket, right? Docker.sock. And we're not going to go into this in too much detail. I'd recommend checking out a talk from Ian Colbwater and Duffy Coleman at Black Hat this year. It's called, I can't remember the name of it, something host, but they had a great talk on mounting Docker socket, the ramifications of that, and those sorts of read-write mounts and what kind of problems can persist to help you, perform this type of container breakout attack. So containers typically restrict the number of Linux capabilities that are granted to it, right? That's the whole point of containers. That's why we use them. And over the years, that's gotten pretty good, right? That's been a fairly battle hardened and tested sort of thing where it's like this container can only do certain things to the Linux kernel, right? But privileged containers throw that completely out the window and allow you to actually have dangerous capabilities to the container itself. So really quickly, I just wanted to show you the difference between a privileged container in Docker and a non-privileged container. And we're going to use capsh to do this. This is kind of a classic container security demo, but it really kind of drives home the what one single flag can do to your security capabilities, right, of your container. So here I have a Docker run command, and I'm using the image of Alpine latest. It doesn't really matter for this demo. And I'm going to I'm going to install libcap and capsh, and we're going to run this command and see what capabilities using capsh that this particular non-privileged running container has. And this is standard container privileges, right? And it's all right here, right? Here's our list. So if I were to, let's see if I can do just actually, I didn't test this, but, and I'll make this bigger in a second. And if I run this as privileged, and we'll just look at these side by side, let me zoom in a little bit. You're going to see the privileges just by running this different command that is docker run -- privileged. And again, I know this is a Kubernetes talk, but this translates directly into a Kubernetes configuration that is often overlooked and adds a lot of attack surface, right? So if we look at the difference in the capabilities on the Linux kernel, right, and there are hundreds of these things, right? And if you look at what a non-privileged container has, it's fairly minimal. And we're definitely not going to go through all of these capabilities. But there is one that I want to talk about, and it's capnet admin. And there's one more, but we'll talk about this. So this is kind of a catch-all privilege that this running container has now that lets you do scary things like bind to host ports, mount volumes, do all sorts of scary stuff on the host itself. So when you run this -- privileged flag, you are basically throwing all of the security controls out the window. Yeah, it still looks like a container because it's using Docker to build the container, but you can do all of the bad things that you would on a host running as root, right? So we want to avoid the privilege flag if at all possible. Let's hope this comes back. Okay, it did. And again, we're talking about containers, but we'll see what the privileged mode of a pod looks like as well in Kubernetes. So image integrity. I don't spend that much time on this anymore. I don't have a ton of sympathy for people who pull third-party code straight from the internet and run it in their production AWS or cloud accounts. This has been a problem for basically since the beginning of modern software development. And now it's still a problem as we move towards containerized environments, right? We have these public image registries, or any image registry, right? And the integrity of that image matters a lot. You're pulling all sorts of packages and binaries and libraries and configuration into your environment and running it. And those could be tainted. They could have backdoors. There could be bugs. There could be vulnerable third-party packages. SNCC can help us with that, right? Go SNCC. And so we need to be really careful with this, right? And this is kind of the hilarious one that happened last year. People were pulling a very popular public Docker image from the Docker Hub into their environments, and it was mining cryptocurrency. They made $90,000 and that's ridiculous, right? We shouldn't be doing this, but it's still a huge problem, and it will persist forever and always, because the easy way out is to pull images that you haven't actually validated. Enough on that. Let's dive into Kubernetes, right? Any questions so far? I'm kind of flying along because I want to cover lots and lots of things and leave a little bit of time for Q&A. And this is the meat of it, right? Containers are what we need to run inside of Kubernetes. I thought this image was very telling of what Kubernetes looks like that's misconfigured, right? It's a bunch of containers about to topple over into the ocean. And we're going to discuss briefly what Kubernetes is, what it does, why you should care, and then kind of what are the defenses. Like, we have these certain container configurations that we can set and create, but how does that even like make its way into Kubernetes, right? And that path is a little murky sometimes. So at its core, Kubernetes is an open source platform just built to take what you have as a running container or a Docker image and actually send it out into the world, right? It's for deploying your service, your application, your backend webhook, whatever it is that's running in a container, and get it actually provisioned onto some compute, some virtual machines typically. So it handles things like scaling and orchestration. So what does that mean? Scaling means I can have one container inside of a pod running, or I can have 50 of those pods at any given time, and it's very elastic. So once you kind of provision your workload onto the cluster, Kubernetes is going to be how you kind of puppeteer your fleet of containers, your different services and microservices and deployments, and all the things that make your application do what it does. It's extremely, on a side note, it's extremely flexible, right? So the flexibility is what gives Kubernetes this kind of allure to be, number one, API driven, and number two, deployed pretty much anywhere and using any type of workload. So we're starting to see Kubernetes at the edge, seeing Kubernetes in IoT devices. Probably it's running in vehicles, right? I would wager. And Tesla uses Kubernetes to collect a lot of its data and process data coming from its vehicles. So it is very, very flexible with the type of workloads that can run on it. No questions so far. Everybody's a Kubernetes expert. So we're going to just breeze through a little bit of intro still, and then we'll dive into the state of the security pieces of Kubernetes. Time's at 9:30. Okay, almost 9:30. So in short, Kubernetes is kind of a pile of Linux goop, right? It's a lot of things going on under the hood that are written in Go, and basically Linux kernel primitives and features of the Linux kernel itself, such as IP tables, etc., and that are combined together to become this system, right? It's a distributed system in a sense, but it's a lot of things that are written by third parties, code written many, many years ago, and it is come together to give you this very clean, easy to use API and what's called the control plane to manage your workloads and your fleet of running containers, essentially in the form of pods. So I thought Kubernetes is secure by default, right? Google kind of made this thing and open sourced it, and everyone talks about it, but it's not, right? So that's kind of the thing I want to drive home. The defaults of Kubernetes are not secure. There is hardly even this notion of a default Kubernetes kind of system anymore, right? You can deploy Kubernetes a ton of different ways. There's many bootstrappers, kubeatom, kops, kubecorn, et cetera, and there's also managed Kubernetes, and then you can roll your own Kubernetes. So there's hardly even this like one-stop shop to say this is Kubernetes. And there's different versions and different components, and now we're seeing forks of Kubernetes as well. So it is a living, breathing organism. So Kubernetes as a project has always optimized for flexibility, right? And extendability over security. And that's not to say security was ignored. It just didn't become part of the ethos early on as Kubernetes became popular, as most open source projects are, right? So it's just code that people are trying to get running, and it evolved over the years and bolted on security with a lot of major releases. And to me, that's okay, right? We have to understand what Kubernetes is, what it isn't, and all the knobs and levers you need to pull as a security professional to make sure that this is like a secure, sane system to be running your production customer workloads. Again, security is never done in Kubernetes because it's a living, breathing system, right? You can't just take a snapshot once a quarter and scan your cluster and be like, well, I think I'm good now. I'm just going to do this again next quarter because the auditors told me to. It's never done. It's a continuous thing because the way Kubernetes shifted our SDLC and how we do continuous delivery and continuous deployment has vastly changed this ecosystem, right? We have all these components that are automatically updating. We have new workloads being provisioned. We have nodes coming and going through auto scaling. So it's a very interesting topic, but it's not static by any means. And we'll see how in a minute. So to kick things off with the kind of what can go wrong sort of scenarios inside of Kubernetes, we'll start with the easiest one that I hope nobody falls prey to. This is this was Tesla's Kubernetes dashboard exposed to the internet in 2017. I know it's like, basically forever ago in the land of Kubernetes, but still it's a thing that happens. And they were storing AWS access keys and secret access keys inside of Kubernetes secrets, which are accessible by the dashboard depending on how you have your role-based access control set up. So this is a problem, number one, because if you stumble across this on the internet and discover these keys, load them up in your AWS CLI locally, somebody was able to actually access Tesla's AWS infrastructure and start mining cryptocurrency. So dashboards, be very wary of, and not just the Kubernetes dashboard. There's lots of dashboard plugins and third-party components coming out almost weekly at this point, and you have to really read their configuration, right? You can't just say kubectl create -f random YAML file and spin these things up, because you could be creating public load balancers. They could have horrendous RBAC policies, and they could just be doing bad security, right? And if you don't need this dashboard exposed to the internet, which nobody really does, just eliminate it, right? These dashboards aren't even that useful, and just run them internally. Another kind of more intricate sort of problem that we're going to see lots and lots of in the future would be web application vulnerabilities such as SSRF, right? Server-side request forgery, which a lot of us here on the Secure Developer are probably familiar with, right? SSRF leads to different major problems in containerized and cloud environments, right? So this is from Shopify. They have a web app kind of tool thing called Exchange, and somebody found SSRF in it. Yep, that might not be that big of a deal. Maybe it is, but they were able to use that to basically grab kubelet credentials, kubelet certificates, which is a component running inside of Kubernetes that communicates to and from the API server. It's very privileged, and they could grab that certificate, replay it, and basically just become cluster admin and start running their own kubectl commands on the Kubernetes cluster. So if your application's vulnerable to SSRF, which we should at this point kind of assume that may happen, right? Nobody we don't have perfect application security yet, and it happens. So if SSRF occurs on a running container inside of your Kubernetes cluster in a pod, and that pod can reach out and do bad things to internal IP addresses or the AWS metadata endpoint, or do its own port scan of the entire Kubernetes environment, bad stuff's going to happen, right? The blast radius becomes quite large in that scenario. I suggest that you kind of read this as a how-to guide of I hate to say what not to do, because this took a lot of guts to kind of publish and show the world of like what happened. But there's a lot of defenses that were missing, and then they, JW Player Engineering decided to do a full step-by-step, play-by-play kind of how to fix that, how they fixed a major problem in their Kubernetes cluster. So we're not going to go over this now for sake of time, but it goes step by step. Containers, they basically installed a monitoring third-party plugin called Weaveworks, and that particular plugin had elevated privileges. It was a privileged pod running inside the cluster, and it also ran as root, and it also mounted the Docker socket. It also did a lot of bad things, and they had no idea, right? Because they just installed this thing that somebody pointed them to a GitHub repository for, and they paid some money to do it, and it was all systems go until it wasn't, right? There was a public IP address with a dashboard sitting there, and that dashboard had a little terminal, a little shell, and that shell gave attackers from the internet full access into the cluster, not only to the running container, to the host operating system as root. So obviously bad things are going to happen when you have a public IP address that's this vulnerable. So check it out. It's extremely enlightening. I use it in my classes as like the final play-by-play of like, here's what we learned, and here's what we learned, how we could have protected against this. So here's, we have CVEs, right? We have sort of Kubernetes showing up in all the main channels that we kind of subscribe to as security professionals to patch, right? So CVE 2018 10020 or 2105, that this is a great deep dive, right? Ian Coldwater again at KubeCon KubeCon Europe this year did a deep dive into this CVE. But when things go bad in Kubernetes, it usually has to do with privilege escalation or some sort of remote code execution, and it's usually critical, right, or high. We're seeing a lot of these come up because it is such a complicated system. So please subscribe to these bulletins if you're running Kubernetes internally, and keep up to date with this, because they're pushing out fixes relatively quickly. But if you're not running managed Kubernetes, it's on you to go patch your version of Kubernetes. No questions yet. So real quick, this is kind of a hodgepodge Kubernetes threat model. For sure, not a formal Microsoft threat model by any means, but this is just to go over kind of, and I know I didn't talk about like what Kubernetes is from a detailed perspective. That would take over an hour itself. But I think it's more important to go over what the threat model is, at least for just trying to convey this information, get it out there. And this is my threat model, definitely not yours. And this is not going to cover all the things, right? So just keep this as kind of back of the napkin sort of threat model of Kubernetes that came from my head. So number one, we have user compromise and insider threats, right? There's maybe a cluster admin account compromise. At the end of the day, we're storing credentials in what's called a kubeconfig file. How do you get those credentials out? Do you have MFA in place? How's authentication happening? Who has cluster admin? Are your administrators the entire engineering org? Well, that'd be bad, right? And are people checking these credentials into Git? Are you rotating credentials? All sorts of things can happen with cluster admin account compromise, right? Onboarding and offboarding, basic security hygiene 101. Rogue employee hard thing to defend against. We're going to talk about RBAC, and that's kind of our way we limit the scope of what can happen there. And then I just added this, but build system compromised, right? So Kubernetes isn't really its own standalone unit. It's usually tied very intricately into build systems, Jenkins, or other kind of runners or CI/CD build pipelines that are off doing work for you in automatically deploying your pods or your any of your Kubernetes workloads into the cluster. So those build systems have access to the image. They have access to secrets generally. They have access to the Kubernetes API via service account token. They are basically a privileged user. So if you can taint that build pipeline, you have then compromised the Kubernetes cluster potentially. Application vulnerabilities, right? Just because you're running these things called containers, that does not mean you're off the hook for doing your AppSec work, right? Authentication, authorization of the app, but also the Kubernetes components, cryptography. Don't roll your own. Use industry best practices, et cetera, et cetera. App and API vulns, right? RCE, remote code execution, and SSRF are going to be the big ones in Kubernetes that we're going to see manifest and escalate to cluster compromise or even cloud account compromise. And then insecure third-party components. We're pulling in other people's code into our applications and our clusters and running it. Obviously, bad things can happen. Use SNCC. Again, they're going to help you with that. So on to network and infrastructure. Kubernetes networking is detailed, it's intricate, it's got a lot going on. We didn't dive into that. That's another hour talk. We're either using IP tables or etcd or other mechanisms inside of Kubernetes to actually handle how a pod talks to the outside world and how pods talk to pods. If we can compromise those things or kind of do some sniffing style attacks, we can read traffic in plain text, right? And I don't have a slide on service mesh, and it's worth a mention. I didn't put it here because again, this is typically a 2-day class, so I'm trying to really cruise through as much as possible, but a service mesh is going to help you here to an extent, right? It's going to give you mutual TLS authentication and encryption inside of the cluster. We have options such as Istio. I got our first comment from Alex. Octant is a fairly good replacement for the Kube dashboard, runs locally and uses your Kube control permissions to show data. Octant is a replacement for the Kube dashboard. That is absolutely correct. In your second comment, but I've never found those dashboards very useful. That was actually going to be what I was going to say. Use whatever you want for a dashboard, but don't be silly and open it to the internet, and definitely be very mindful of the capabilities that it has, right? So use Octant if you want. It's a thing, and so is the Kubernetes dashboard, and so are the many other dashboards that are out there. Kernel and OS system vulnerabilities, right? At the end of the day, your Kubernetes cluster is just running on a collection of virtual machines. Those virtual machines are running Linux, right? Some version of a Linux operating system. So you need all the standard hardening that you had before in place to make sure your cluster doesn't get owned through regular old attacks that we've known about for a long time, right? Container breakout and unauthorized access to the control plane. Those are the bad things that can happen. So container breakout is preventable to a degree, right? In my ideal world, I would have a cluster that's hardened to the extent where I wouldn't really care if I could run some sort of completely misconfigured, vulnerable, awful container, right? I have controls in place in layers of controls that are going to stop container breakout from ever occurring. Denial of service, right? This certainly doesn't go away in Kubernetes, and Kubernetes has become this very, very ripe cryptocurrency kind of malware target because it is so elastic, right? It is such a great platform for cryptocurrency to be mined on. It's auto scaling, and horizontal pod auto scaling, vertical pod auto scaling. All these things really help cryptocurrency miners work. So watch out for a certain container or a certain process on a virtual machine, eating up too much CPU or hogging resources. This is going to lead to crash or worse, financial exhaustion, right? If you have auto scaling on your managed Kubernetes clusters enabled and you allow your clusters to scale to 100 nodes and somebody does that and it automatically scales, you're going to spend a lot of money. And then again, image pipeline, right? The image pipeline matters a lot. The integrity of it matters, and the lack of vulnerabilities is key, right? We don't want to be pushing images into our cluster that's riddled with critical CVEs and things like that. And then, end of the day, it comes down to misconfiguration being kind of our top problem. It's either, lack of understanding, increased complexity, disparate teams, early adopter, whatever the reason is, misconfiguration just happens, right? Open ports, things you put in place for testing that never got removed. Maybe you had some cluster admin RBAC policies for everybody, and you're like, well, I'm going to fix that later, right? Well, the person who said they're going to fix it later doesn't work at the company anymore, and this is just how we do things. That's really, really common, and it's unfortunate because you're just opening yourself up for actually imminent doom. So passwords, passphrases, don't check them in to Git. All the things we've learned about, we know about. Use MFA, use strong authentication. Don't use basic HTTP basic auth. Really lean on your SSO mechanisms and your OIDC and your OAuth 2 mechanisms you've already built from a corporate perspective. And there's probably a way to plug it into Kubernetes and just forget about it, right? Network segmentation. So don't have publicly available public IP addresses tied to your entire Kubernetes cluster, right? That could definitely open you up to some problems. And just, you need to at least have that base knowledge of like, should our cluster be in this VPC? Should we have VPC peering across? What can access the dev and test cluster versus production? There's all those decisions that need to be made early on in your journey. So in short, we really want to limit our blast radius, right? And what do I mean when I say blast radius? If and when bad event occurs, what are the kind of like, how can that spiral out? How can that really extend itself to other parts of the environment and the system, right? So if I'm vulnerable to SSRF in my API, way deep in the back end, is that going to lead to cluster compromise? Is that going to lead to AWS account compromise? Because that's what's happening, right? We misconfigure things so badly that one web app phone spreads itself out to totally grabbing secrets and taking over an entire cloud account. So somebody said, would you mind to share some of your real life experience as an incident or misconfiguration in production environment? I will at the end if I have a chance, and if I don't have a chance, hit me up on Twitter at Jim Mesta, and we can chat about that as well. I've probably worked with 30 different large production clusters to a degree with problems with lots of misconfigurations. So I have some very highly redacted war stories I can share there as well. So this is from a ebook called Operating Kubernetes Clusters and Applications Safely. It kind of just gives this visual representation of like what could go wrong, right? So here we have our cluster has nodes. etcd is our data storage mechanism where we store secrets and all of our configuration for Kubernetes. Access to that could be bad, right? If you can access etcd from a web application that's running in a container inside of a pod, bad things can happen, especially if you're storing secrets there. etcd also needs to be part of your BCDR plan, right? Your business continuity disaster recovery plan. So it should be backed up. It should be, all of the snapshots should be sent elsewhere. etcd is kind of this like very central, important piece of Kubernetes. And then we have the kubelet API, container escape to the host, injecting traffic, access to the VMs, misconfiguration, et cetera, et cetera. I don't have time to dive into all these. And if you want to talk further or attend one of my classes, and I didn't mention, I'll be giving a workshop at KubeCon this year on this kind of stuff, hands-on, kind of with a few other folks, highly respected folks in the industry, on basically attack defense style Kubernetes in a big room at KubeCon. I'm really excited. So that's in San Diego in November. Check it out. Defenses, right? What can we do? Like, sounds like we're in a cluster because we are. And how do we start kind of layering defenses on top of these Kubernetes environments and cloud environments? Oh man, I have 15 minutes. All right, let's see if we could get through this. We're just gonna scratch the surface of these because they are big, hefty topics. Number one, RBAC, role-based access control. This is really how we start applying the principle of least privilege. We'll look at that. Container and pod permissions. What can a container do that's running in a pod, and how do we kind of stop that through the use of pod security policies, dynamic emission control, and open policy agent, OPA. Sandboxing. How do we run really untrusted workloads inside of our cluster and even limit what kind of access it has to the Linux kernel even more, right? Thank you, Sam. Yes, that is the tutorial at KubeCon. And then node protection. It's kind of more the boring stuff, but really, really important. Okay, let's go. Role-based access control. This is how we're going to regulate access to resources. This isn't authentication. This is authorization. So we're not going to discuss authentication because there's too many options and everyone does it different. And there's a billion plugins and that's a different discussion. But we'll talk about RBAC because it's the thing I see where most of out in the world, in the wild, of people think they have it right, but it's not, right? It's easy to get wrong and it's hard to audit. So at its core, RBAC ties a user, somebody at a keyboard or a service account, to API resources and allows that a particular user or service account to perform operations, get, list, delete, patch. Those are HTTP verbs, right? So an RBAC policy is just a collection of all these things. It's like me as Jimmy can perform delete and list on the resources of secrets and pods, right? That would be an RBAC policy in plain kind of meta programming English. So what do they look like? We have roles and we have cluster roles. A role is where we define the allow list, right? This is a role called pod reader, and this is tied to a namespace of development. Roles are always tied to a namespace. For the most part, they should be. And we have resources and verbs. So what we're dealing with in Kubernetes, if you're new to Kubernetes, is YAML. So that's just the new language of choice, right? Now, the hot job on LinkedIn is like a senior YAML engineer, right? That's all we care about now is YAML. I'm just kidding. Well, there actually is a couple of roles like that. But so this allows the individuals or service accounts or groups tied to this role through the use of a role binding that we'll see in a minute to get and list pods, right? Not rocket science. And that's all we're going to dive into as far as how this is structured. Just keep note that there are roles, cluster roles, role bindings, which take that user that's right here and binds it to this role, and cluster role bindings. And you as an operator need to build these as an administrator, and the security team better be involved, right? You need to take a lot of time to sit down and think like, okay, like, yes, we have cluster admins. That's easy. We give them elevated privileges. We put them on a pedestal. They have to do all the things in the cluster. But how do we scope this down for a service account that token in Jenkins that only has to do certain things to get its job done? And how do we scope it down for a developer, right, who needs flexibility and freedom in the cluster, but not too much that they can cause harm? This is really helping with that kind of rogue insider misconfiguration sort of part of the threat model, right? And getting these right is hard. And I'm gonna, maybe Sam will remind me, I have a list called Awesome Kubernetes Security in GitHub that has a lot of tools pertaining to RBAC that help you visualize and audit this sort of thing, but they're not bulletproof. So this takes a deep understanding. So RBAC is good. We need to use it. And containers can request elevated privileges, right? Our container itself running inside of a pod can run as root. It can also mount sensitive volumes, such as the root volume. We can request access to ports on the host. The container can run the privilege flag, right? It's all the same Docker stuff, and Kubernetes just surfaces that up through YAML. So the one that we need to look out for is privilege mode, right? it's in our pod specification. And if we allow our Kubernetes cluster to run privileged pods, we are saying, I don't care about security. I'm just going to basically break down the walls of what we had as a running container and run this as privilege mode. You're going to see a lot of monitoring, alerting, and network kind of overlay pods requesting this. If you trust it, go ahead, right? But you better know that you're running privileged pods and that it's part of your threat model, right? So how do we defend against that? How do we say as a cluster admin, hey, or a security pro, like, I don't want this stuff running in my cluster. I just want to firewall it off. So we use one of three things. One is a pod security policy. This gives you the ability to, yes, I will get the list for you, Sam. This gives you the ability to block some of these very risky behaviors at the front door. It's called an admission controller. So it happens at the API server. So we're authenticated, we're authorized, and then we have admission control, and pod security policy is one of those. And we build the security requirements. It's a cluster-wide resource. So we don't really apply these to namespaces. It's applied to the entire cluster. So here we have a pod security policy that helps us block any privileged pods that are incoming into our cluster. So this is kind of pre-flight, pre-deployment. This doesn't go out and search for certain pods that are violating policies. It's just going to go out, just going to stop it at the front door. And we're going to whitelist a couple volumes as well. So I'm not going to spend too much more time on that. What we're seeing people shift to is what's called dynamic admission control. Pod security policies are fairly static. We have a list of things that we allow or don't allow, and those are supported by Kubernetes or not. And dynamic admission control lets us totally customize what we're going to do in the form of admission control. We'll call this our pod firewall, if you will. So we're going to intercept requests coming into the cluster, check for certain configuration that we allow or don't allow or want to add configuration, and then we either block, allow, or modify and submit that to the cluster itself. So this is kind of the future of doing Kubernetes security, in my opinion, right? Pod security policies are great. They work out of the box, but these take a little more work, but they're going to give you way more flexibility. So if we want to do something like, last 10 minutes, deny, so this is a example from Kelsey Hightower. This will reject pods that use environment variables. We can't do that with pod security policies, but we can with these custom admission webhooks. And even further, to add to that, without going deep into the weeds of what OPA is and does, Open Policy Agent is going to help us kind of do this cluster-wide and across multiple clusters to basically apply security policies with a standard language. And I'd suggest, if you're interested in this and really getting in the nitty-gritty of OPA and what it does for security, check out the Project Gatekeeper. It's a policy controller, so it performs a webhook in the form of admission control to run a bunch of checks based off of what you've given it. And you can either deny or allow those requests, or you can mutate those requests that are coming to your cluster. Some examples would be, I only allow pods that have specific labels into this cluster or namespace. Gatekeeper allows audits of violations of policy as well into a running cluster, which is really cool. And maybe you want namespaces to have a label with an owner, right? That's for cost or for any sort of reason that a dev team needs to put a label on their particular namespace. Or if you require that your containers have resource limits. Hey, I only allow containers with 250 megs of RAM or your CPU units, whatever it is. I'm going to stop that if you don't have limits defined that are within my parameters. So this is where security people should be focusing, right? So again, the easiest of this, always ensure images come from a known good source, right? Use SNCC to scan your container images, and there are other tools out there, but they're all horrible, right? Use SNCC. I'm just kidding, but verify that image is good, right? Doesn't have vulnerabilities. Do integrity checking. Cryptography is appropriate here, right? You can cryptographically check the validity of that image right before it's about to be provisioned into the cluster. check out tools such as gvisor and kata containers to really start to sandbox containers in a pod even further. This will act as a shim in between your running container and the Linux kernel, and it's going to even restrict what it can do further and give you a lot of serious protection there at a cost to performance. But if you're running untrusted workloads, you have to be in the know of these kind of projects. And patch your stuff, right? Under the hood, OS hardening, hardened images, IDS, IPS, all the security stuff we've been doing forever and always doesn't go away. They're just VMs. So Kubernetes can be secure, but hopefully after this complete and utter fire hose of information, it's not the default. These are levers you choose to pull and knobs you choose to turn. And if you turn them the wrong way, you may not even know that you're opening yourself up to attack. Take home assignment to you. If you're running Kubernetes, again, I told you there'd be a lot of words here. This kept growing. Ask yourself these questions, right? Can containers run as root? What volumes are allowed to be mounted? Is it read? Is it read, or is it read and write? Can I run pods in privilege mode? What policies do I have in place? Do I have any policies blocking this kind of stuff? How do I do authentication? Step through that flow. Make sure that the individuals who have access should have access. Onboarding and offboarding procedures work as expected. Do you have RBAC? And is it locked down to really apply the principle of least privilege? Where are secrets stored? Are they in etcd? Is that encrypted? How are you bootstrapping secrets? Can you rotate them? Can you revoke them? Where are your images even coming from? Are you allowing images from the internet? If so, why? Do you have network security being enforced, right? How do you audit these rules? Can all the pods in a given cluster talk to every other pod? Well, that's probably not what you want, right? So you need to look into something like a service mesh or network policies that we didn't even talk about today. Are your hosts hardened, right? Don't forget your hosts. And are you using Kubernetes audit logs, right? No one uses these, but they're awesome. These are these logs that are given to you for free by the API server that have all sorts of security goodness built in the form of HTTP requests and responses. Pipe them out to Splunk or Elk or somewhere and set up that as part of your SIM, right? Your event monitoring solution. Do you have ingresses or public IP addresses that you didn't know about? Well, that's a problem. If you have an SSRF bug, what happens, right? What happens if that gets exploited? Can you get your keys to the kingdom? Have you done a threat model? Sit down and have a beverage after work and talk about your Kubernetes deployment, right? Like, what does it mean? Do a threat model. It doesn't have to be crazy formal. And are you pulling in third-party components, right? You probably are. Do you trust them? Have you read the RBAC policies? Have you read what secrets they're storing? Are there web app vulns in those products, right? So those are all the questions that make this quite difficult. This is a really fun, from Duffy Cooley. I said Coleman earlier, but Duffy Cooley. This is a one-line container breakout on a running Kubernetes cluster. And if you don't have any of those protections in place, you become root on the host operating system, on the node itself, if you run this. Beware of blind spots, right? There are too many blind spots to enumerate here in this talk, but there are so many, and they're just going to keep growing. And we're all beginners at Kubernetes, right? I talk about this stuff. I have for a long time, and new things come out every day, right? Somebody mentions a new tool or a new piece of the API or something going on in the cluster that I just have to go read up. So we're all beginners in this cloud native journey. So we have to adapt and evolve, obviously, and give back. The community in Kubernetes is very, very warm and inviting for the most part. And we need security people, right? I wish I gave back more. That's why I'm here, and that's why I do a lot of conferences and things. But we need security representation and folks looking at this stuff in detail. And the future, so flexibility will still, overpower security, and that's our reality. We have to embrace it. So we have to choose our own adventure. There will be more tools coming out. Those are good, but I'm not sure the tools are going to solve all our problems. Tighter cloud integrations. This will happen. It is happening. Use managed Kubernetes and GKE It's very different than rolling your own Kubernetes, and you get some serious security benefit when you start really tying into the cloud. But is that what you want? Maturity is already seeing a big uptick. The big kind of security problems are somewhat addressed in Kubernetes. Now it's up to us to make those more mature. And as we get better, obviously our adversaries will learn and get better as well, and Kubernetes will become more of a target. So some practice, I have a very, very early project called KubeGoat. It's a vulnerable Kubernetes cluster. I'll paste a couple links also into the Slack of some resources, but there's lots of goat things, right? Goat things that help you test against Kubernetes, intentionally insecure Kubernetes environments. Whew. Okay, so hit me up at Jim Mesta on Twitter, jimmy@ksoc.com. It's been a pleasure. I hope that wasn't too fast. I can't believe I made it to the end. Thank you very much, and hope to see you all around. So don't be shy and reach out if you have any questions whatsoever. Sorry I didn't get to your question earlier. We could talk on chat later. And I made it, 10:01.
Woohoo! Well done. Thank you so much, Jimmy. That was amazing. And I'm sure everyone who is listening enjoyed it as well. So huge thank you. Hopefully it won't be the last time we have you on the Secure Developer, but a great first time. Right, yeah. So for everyone listening, and maybe you're listening to this post-live session, please, if you have any questions for Jimmy, he's part of our Slack group, so feel free to pop your questions in at any point, even if it's a month or two in the future, and I'm sure he'll be happy to answer those, as well as on Twitter and a few other places, but thank you again. If you enjoyed it, please share, retweet, tell the world about it. And as I said before, if there's anything you want to hear about, let me know. This community is for you, not for me. Well, a little bit for me, but let me know. We can find great speakers for you. Our next session is actually in 2 weeks. It's on the 10th of October. And we're going to be talking about automatic least privilege in AWS with Travis McPeak from Netflix. So please join us for that. And other than that, I hope you had a great day, evening, morning, wherever you are in the world, and we'll see you all again soon. Thanks again, Jimmy.
All right. Yep. Bye, everyone.